Hi, this is Mrs. Zhu, and we're working on the practice final for quarter 3, number 2. This goes into page 41 of your notebook. It's the last page of the notebook before our notebook check next Wednesday. And the notebook check will include everything that is in your notebook from page 25 to 41. So just page 25 through 41. As you look at this homework assignment, I also passed out to you a worksheet in class today from page 40, and that worksheet actually would probably be a little bit more helpful as you prepare for tomorrow's final, in covering some things such as tax and maybe some things that aren't covered in this specific practice final today. But study both practice finals to help you for tomorrow. Number 1, when you're looking for scientific notation, we start with 47, and million has 6 zeros after it. So if I take that standard notation number and write it in scientific, I would write 4.7. The decimal goes between the 4 and the 7. That number, remember, has to be greater than or equal to 1 or less than 10. And I'm going to multiply it by 10, and every time I move the decimal, it's a power of 10. So 1, 2, 3, 4, 5, 6, 7. And it's going to be a positive 7 instead of a negative exponent because our number is larger than 1. Let's skip over to number 4. If I want to write 5/8 as a fraction, I'm going to divide them. So the number on the top goes in the box. So 5 goes in, 8 goes out, put a decimal there. 5 can't divide by 8, but it could divide 6 times with 50, giving me 48, 20, 16, 40, and a 5. So 0.625 is the same percentage as if I move the decimal 2 to the right, and I always move 2 because percents are represented as out of 100, and so that is why I move twice. C. Number 5, which number is irrational? I know that fractions are not irrational. Decimals that terminate are not irrational because I could write it as a fraction, 35 over 100, and then simplify. Repeating decimals are also not irrational, but the ones that are irrational, they're like the decimals that kind of go on forever, just like pi does. Number 3. I'm going to take 1/2, add it with 0.5, and then add it with 2/5. 1/2 is the same decimal as 0.5, and I'm going to add 0.8, and then add 2/5. 2/5 is the same as 2 divided by 5, which is 0.4. So that's 0.4. So if I add them all up, I'm going to line up my decimals. I don't even really need the zeros if I don't want to have it there. And if I add them all up, I get 7, 1, 1, and then 0.7. Number 6, the answer is going to be D. That is my rational number. Don't really need to explain much of that page right there. Okay, on number 7, we are, you can I think do that by yourself. Let's do number 9. We're looking for the percent increase. In your worksheet from class on numbers 1 through 4, we did exactly a percent of an increase. We always use the formula percent over 100 equals D over O, do the do, and the D stands for difference, and the O stands for original. So I'm going to take the difference of the two. I'm going to take 150 minus 225. Actually, I'm going to subtract the bigger from the smaller, and then I'm going to divide by the original. Originally, the number of tickets that they sold was 150 because it says that they increase their sales and the next day, from Wednesday to Thursday. So that's the original. So if I subtract 225 minus 150, I'm going to get 75. So 75 divided by 150, I can divide both by 25, and that 25 represents like a quarter. So if I have 75 and I want to divide by quarters, I need 3 of them. $1.50 divided by a quarter would be 6 quarters, which is the same as 1/2. And that fraction, I could put it in my formula x over 100 equals 1/2, but I also know that half is really the same as 50%. So my answer is B. Number 9 is just like similar to number 9. Number 10 is similar to number 9. So you're going to do the same thing. Number 11, I'm looking for the profit. Now, to find the profit of the vase, the profit just means like how much they make. So it says that she sold 350 dollar vases, and she sold 17 of them, so I'm going to multiply that. And I'm going to get $55.25. Now, there was some money that he had to spend to buy the materials, which was $16.21, which then I'm going to subtract that because, you know, I didn't earn that. So $16.21, when I subtract it, I get $39.04. So that's going to be C. Okay, number 12 is a discount question. I'm not going to help you with that. Maybe do 14 again, talk about slope. The lines, the dots you should pick would be here, here, maybe here. Okay, maybe down here as well. Okay, and when I count up over my slope, okay, my rise is going to be up 2, and my run is going to be right 3. So that's my fraction, and I know that it's upward sloping, so it's going to be positive. So I'm going to look for the positive answer, which is going to be C or D, and it's going to be C because C represents rise, run. This one is incorrect, D, because it's run, rise, and we don't want run, rise. Okay, and then clearly not A or B because we don't want the negative answers. Going to the next page. Let's look at number 15. We want to know how much they're getting paid hourly. Now, we can tell that right here for 1 hour, it's going to cross 1 hour here. It's going to cross a little bit under the $20. So if I look at my answers, then definitely the only answer that is less than that would be A, so $15 an hour. Look at number 17. I want to look for the area of the carpet, and the carpet is actually measured in 270 feet squared. Okay. Now I want to measure it in yards squared. So let's just say that the room happened to be 27 feet and 10 feet. And the reason I'm going to do that is because, well, okay, let's not do that. If I want to figure out how many yards squared, I have to figure out the conversion of feet to yards. There's actually 3 feet in 1 yard, but if I have feet squared, okay, if I square it, if I multiply another foot and another yard, then what I'm going to get is that for every 9 feet squared, it's a conversion of 1 yard squared. So if I have 270 feet squared and I want to find how many yards squared, I'm going to make a proportion for us just to help us understand that. And I know that this is my conversion rate. Then I'm going to do 9 feet squared is the conversion rate of 1 yard squared. So then I can directly do cross multiplication. So 270 is equal to 9x. So then I'm going to divide both sides by 9. And that's going to give me 30. And so 30 is my answer, B. I know that's kind of a difficult question. We didn't talk about that much in class. But helping you set it up in a proportion, I think, is helpful. Number 18. Number 18, you can also set it up in a proportion. It's a specific rate. We've got miles, hours, and then again, how far in hours. So we've got 190 miles for every 3 hours, and we can make how many miles for every 7 hours, and we can do that and cross multiply. The answer you should get is A. I'm not going to help you with the next slope question, but let's try number 21. In number 21, we have this flagpole. That's 20 inches. Now, there's a little key here that is kind of like a ratio. So we could write a proportion, 1 inch for every 1.5 feet. And we can do the same thing for the actual size of the flagpole, which is 20 inches. But look for how many feet it is, because inches is the model, but feet would be the actual height in real life, the actual. So then I'm going to cross multiply. I'm not going to work that out for you, but the answer will be B. Number 22, you want to do, this would be kind of like a friends and family question. Okay, and I'm not going to do that for you. 23, you can actually skip, but if you were able to kind of make a guess, square root of 11 is about close to like square root of 9, bigger than that, but also smaller than the square root of 16. So that's where, so it'd be anywhere about like 3 point something, maybe 3.4, maybe about. And then 61 is about the in between the square root of 7 and the square root. Oh my gosh, I'm saying 9. Oh, I'm right. Square root of 49 and the square root of 64. So it's somewhere in between there, maybe like close to 8.5 or something. And this is 1 and this is 11. So if you look at the picture, what do you think x might be? Would it be 1? Seems kind of small for it to be 1. Maybe 3.4, maybe kind of looks like 8.5. Well, I don't think it's bigger than 5 or 6. And 11, it's definitely not going to be 5 and 6 added together, because that's kind of big. If I wrote 5 and I put it next to 6, that would just be a line. It wouldn't even make a triangle. So B. Just if I took a guess, but really you could skip it. We didn't actually learn that. And we'll try the rest with the absolute values by yourself, and we'll see you tomorrow.